All right, hello everyone. Can everyone hear me at the back there? Yeah? Great. So my name is Jeff Harris, and I'm an engineer here at MuleSoft. And tonight I'm going to present a project that I built called RESTful Doom. So this might seem like a really weird question to ask, but it's the reason why I'm standing up here tonight. And this project kind of began as I was searching for a fun API for a previous demo that I needed to do. And I was kind of stressing out. I couldn't find an API that was fun, that would kind of meet my needs. And I was kind of thought, like, I just have to build an API myself. And this is a true story. I was driving late at night. I was picking up some takeout. And it just kind of popped into my head, like, what if we can build an API for something that has never been designed to host an API? Maybe like a game, maybe like a really old game. That would be kind of cool. So show of hands, who's familiar with the REST API? I assume most people are going to put up their hands, a few people not. So a REST API is an API that adheres to a few common tenets. So resources have a persistent URL. You use a common set of HTTP methods, get, post, put, delete, and you use common status codes to return the result. So in this example, to modify an object in the world, you would always use these URLs, and the difference would be the HTTP method that you use. That's kind of a REST API. Who's familiar with the classic video game Doom? Okay, cool. Maybe not quite so many, but most of you, that's great. So Doom was made in 1993 by a small company called id Software, based in Texas. And it became one of the most significant and influential games of really all time. According to Wikipedia, in 1995, more computers were running Doom than Windows, which is pretty awesome. I don't know, maybe that's true today, maybe. Cool story about id Software. So these guys started up as like a tiny little company based in Louisiana. And these guys met as they were working for a magazine company. And they decided they want to make their own games, right? And they didn't have any money, they didn't have any computers. And so what they would do is they got to Friday night, and they'd wait till everyone had left the office. They'd drive their car up to the office door, get these beige desktop computers, load them into their cars, get the big beige CRT monitors, if you guys remember back then, and go and drive off to their house, work on the game all day, all night, all the next day, all the next night, and come Monday morning, they'd race back into the office before everyone turned up, unload the computers, and put them back in the office. And that's how they made their first game, and that's how the company got started. Another really cool fact about id Software is they have this really cool open source policy. So after a couple of years of the commercial release of a game, they open source it, because that's how they learned to make games, so they want to kind of give back. So in 1997, this game called Doom was open sourced. So everyone can look at the source code and potentially kind of work on it. And that's why we're talking about this game today. So you might be wondering, okay, we know what REST APIs are. We kind of already know what Doom is. What is RESTful Doom? So RESTful Doom is a version of Doom that I've hacked in to host a RESTful API. You can control game objects and manipulate the game state using just HTTP and JSON. And it's kind of like a fun experiment just to see, like, A, is it even possible to write a REST API in like a low-level language like C, using no API framework, embedded into a game that was never designed for an API. And in fact, the game was made like 7 years before the REST API specification even came out. So all these pieces together made this like a super fun project to work on. And if we think of all the pieces that we'll need to host a REST API in the game, we need TCP, we need to parse HTTP traffic, we need to parse URLs and query strings, we probably need to handle JSON, since that's like the data format that everyone uses these days. So those things, okay, we're going to have to deal with. On the plus side, this old Doom game engine, this is all written in straight C. No C++, no Java, no private methods, no private variables. Everything's kind of global. So for example, like the list of monsters is literally like a global array. So if we can get our hooks into this game, we can control everything about the game. Nothing is private to us. But hang on, wait, this is 1993, right? This game came out 24 years ago. It doesn't have any of this stuff. It doesn't have anything to do with HTTP or JSON or TCP. It doesn't even compile or run on OS X, right? OS X didn't even exist. So the first thing we're going to do, now we kind of know what we want to do, is to grab a Doom source port. And a source port is something that a maintainer has grabbed that original source code from 1997, and they've modernized it so it can run on modern OSs. For this thing, I chose a source port called Chocolate Doom. And the nice thing about this one is that the maintainers have done the minimum required just to make it run on OS X and Windows and Linux. All the source code is identical apart from the pieces that touch the graphics, the keyboard, the network. Otherwise, everything else is as it was in 1993, which is what I kind of wanted. So now I have my source port, I can compile it on OS X. I know I kind of want to make an API, but now I need to design my API. And so when I got to this point, I kind of looked at the entities in the game. I looked at kind of what those entities could do and the kind of state that they can have. But there's like a challenge of, like, how do we deal with things like, I don't know, like the player needs to jump, or the player needs to run forwards, or press a button. You know, how do you control those things in like a REST API? That was a challenge. So what I did is I designed the API with RAML. And the nice thing about that is at that point, now we have this API spec. In theory, anyone can derive a client from that specification without kind of looking at my janky C code, which implements the API, and actually consume the Doom API for their own purposes. Now, I have a link here, but I probably won't have time. If you are interested, come and see me afterwards. So some of the entities that we're going to control in this game. The first one is the world. So Doom has a mix of episodes and maps, and so each map we identify as part of the world. We have the player, of course, who has a weapon and health and armor and ammo. He's an entity we want to be able to control, for sure. We have this thing called map objects. So for example, in this screenshot, we have a barrel here. So that's a map object. And these things have a position and health and a bunch of flags to decide how the game can use it. We want to control those things, for sure. And we have monsters, of course, the most important thing about Doom. We want to be able to control these monsters. We want to make them do things via our REST API. And doors. So just like in the real world, doors in Doom can open, can close, and sometimes you need a key. We want to control these. So that's our kind of list of entities. And here's a quick screenshot of the API spec that I was talking about before. You can see some of the methods and resources that we're going to identify here. I'll go over this in the demo. So now that we have Doom, we have our REST API specification that we want to do. Now we need to actually implement this thing, which is where it gets kind of tricky. So Chocolate Doom uses a library called SDL, which abstracts away things like keyboard and graphics. It also provides like a simple wrapper over TCP. So cool, we've got that. We're going to use that for our TCP stream. We're going to parse HTTP requests with custom code. We're going to need to generate some kind of valid HTTP responses. That's going to be custom code. And we're going to need to map the user's input down to actual code that manipulates the game world, which is what we're going to call routing. So we route a particular method and URL to a particular controller, which goes and manipulates the game. And we've found a JSON library that we can do JSON with. So here's what an HTTP request looks like. On the left-hand side is what you would use in curl. On the right-hand side is what it looks like when it comes straight off the wire when we're looking at like a byte stream on TCP. Luckily for us, there's really only a couple of things that we need, right? We need the HTTP method, we need the path, and we need the body. Everything else we can basically ignore. And so writing some pretty simple C code, we can get those things out. One quick pro tip is to make sure your strings are null terminated in C. Even if it looks like they are, make sure they are, because otherwise you'll overwrite all the memory and the game will crash and you'll spend 2 hours trying to figure out what on earth was going on, like I did. an actual request going all the way through the different layers to talk to Doom. So in this case, we're going to modify a world object. And we know we're going to modify it because we use the patch method. And we're going to modify API/world/object/ID. So the first thing that happens is Doom is a game, right? So it has to refresh the screen 60 times a second. So this dProcess events is the original Doom method that runs 60 times a second. And I've modified that to call our API handling code. Inside of that, we need to be really careful not to disrupt the game loop, because we can't just sit there and wait for traffic. We need to refresh the screen 60 times a second. So we check and see if there's any data on the TCP socket. If there is, we parse the request, and we route the request to a particular controller. Then we call the controller method, which in this case is patch world object. And then that method itself manipulates the game world in the Doom memory and returns a response. This is the flowchart. Come and see me afterwards. These are the methods that we call. So if we want to jump kind of even further down, like one level down, this is what something like patch world object controller actually does. So a map object in Doom is represented by this thing called mobj_t. It's a pointer to a map object. And each map in Doom is a mix of sectors. And so what we do is we need to find the map object that the user asks for by iterating through all the sectors and all the items in the map to find it. And then we use our JSON library to pull out all the JSON fields that the user set and call the existing Doom methods and set the fields on the existing Doom objects. And that's how this thing really works. We modify the objects in memory. I love this animation. Does anyone want to see the demo? Should I just stop talking now? Who wants to see the demo? Yeah? Okay. I'm just going to put this up here because I'm going to need my hands here. Okay, nice. Now I can see what you can see. So first off, what we're going to do is run RESTful Doom. So what that means is we're going to run the makefile and compile it, and then we're going to run our Doom API. You guys, is this familiar to you guys who have seen Doom? Pretty cool, right? So this is Doom. This is the game as it is, as you remember it. However, this game also runs a RESTful API. So by default, we listen on port 6666, and I'm going to make a request using Postman. There's no smoke and mirrors here, and I'm going to do a get on API/world, hopefully. Okay, cool. So the game has responded with a valid HTTP response with a 200 status code and valid JSON. And what it's telling us is that we're running episode 1, we're on map 5, and the lights are on. So let's make it interesting. What we want to do is now we're going to patch the world, right? Because the world is just an object, we can patch it, we can delete it, we can do whatever we like with it. We want to do map 1. Now we're on map 1. And you see the response back from the API tells us we're on map 1. Maybe we want to get information about the player. So what we're going to do is get on API/player. Hopefully you guys can see that. It's a little bit blurry. So our player has a position, it has a bunch of flags, and a bunch of weapons that we have. Let's make it more interesting. Let's patch the player and change the weapon via our JSON REST API. Now we can change the gun via REST. I can change the gun to whatever I like. Everything is controllable. So we can also find out about objects in the game world. For example, here are a couple of objects, these lights here. So what we're going to do is a get on API/world/objects. And we can pass a distance query string, which limits the amount of objects that we get returned. So in this case, we get a JSON array back. This is all just completely valid return values. We can see a barrel, we can see some health potions, and we can see one of our floor lamps. So now we can query the world. We can get access to all of these objects just via a standard get call. But let's make it more fun. Let's create our own objects. So right here, I'm going to post a new item in the world. We use post for creation. I'm going to say I want to create a barrel, and I want it to be 300 units of distance away from me. There's a barrel. I'm just going to make the music a little bit quieter. Is that better? I'll turn it up later. Let's create another barrel, because barrels are fun. So now I've created a bunch of barrels. These are barrels that didn't exist in the game world that we've literally posted to our REST API that are now literally part of the living game world. So for example, this barrel here we've just created has an ID of 94. Maybe we want to delete it. So we're going to make a delete call on API/world/object/94. Here it goes. It's gone. Maybe we want to create a monster. The nice thing about this monster is we've set the angle field. So we set him to be looking away from us, so he can't see us right now. Maybe we want to create another monster. And this one's also going to be looking away from us, so he can't see us again. And now we can modify these monsters. We're in total control of this game. So each monster has a field which is called attacking, which tells you which object it should attack. And so the two objects we created are object 1003 and 1002. So now we're going to tell the guy to attack the monster. And now he's attacking the monster just like we told him to. And now this guy is going to try and kill me. But that's okay, we can kill him. The other cool thing about Doom is it has doors. And so we can make a request to API/world/doors. And we get a list of doors back, which is again just a standard JSON array with standard JSON objects that you could use from any client. So let's see how that works. I happen to know there is a door right here. And if I make a request again here, I can see the distance that I am away from each of these doors. This door here, which is ID 148, this is close to me. So I'm going to do a GET request on this door. And I can see that the state is currently closed. Let's open the door. So to open a door, I need to modify the door. So I do a patch, and I set the state to be open. There's a door, it opens. As I said, we're in total control of this game. We can kind of do whatever we like here. So in summary, we're controlling 24-year-old code from a modern RESTful HTTP interface. We're using JSON, and we have this documented kind of standardized RESTful API that we can now reuse. So for example, if someone created, say, a Twitter bot which watched for Donald Trump's tweets and created a monster and killed it every time Donald Trump tweeted, they could do that. This code is consumable now by other clients. And the RESTful API scheme actually maps pretty well onto game objects. Like it kind of feels pretty natural to be able to post and patch and delete objects inside a game. And this stuff is just kind of fun. So at that point, just thanks for your time. Thanks for coming out. Thanks for listening to this talk about RESTful Doom. I hope you had a good time. This is a super fun project. I can still remember the first time that I actually got a post working and the barrel fell down the first time. It was very exciting. So thanks everyone. Thank you.
Okay, thank you so much, Jeff. That's awesome. And then next up, talking about is Aldo. Yep. Jeff's question?
Sorry, yeah, of course. I was hoping to quickly get off stage. Sorry, yeah, who has a question? Sorry, what was the question? Yes. No, no tool. So the Doom source code has a bunch of states that things can be in, and I manually created a REST API to represent some of those states. Yep. So the question is, do you think you can deploy it somewhere on the internet? The answer is yes, but it will probably crash within a couple of minutes. You could probably put like an API gateway or something in front to make sure that valid requests come through to Doom. But yeah, someone else told me maybe we should put it on the internet and have twitch.io kind of use it. Should be pretty sweet. Yeah, maybe next time. Yeah.
How much time would it take you to do that completely by hand versus using like a platform like MuleSoft?
So this code is all completely by hand. This is all written in C, kind of inside of the game engine itself. MuleSoft has technologies to allow you to create APIs, but it doesn't work for game engines like Doom.
So there's no platforms out there to help you with that type of thing.
Correct, yeah. So the question was, can MuleSoft help you to build this API into Doom? And the answer is no, sorry. Any other questions? Sure. Here's our CTO who probably has a better answer.
No, I don't have a better. That is correct. It's absolutely correct. We have customers that connect to much older things than Doom, right? To mainframes and COBOL code and a variety of things. Most of those things have some level of API. You usually don't have to go literally into the source code to change it, nor would you still be employing people who remembered what that source code actually looks like. But they have some kind of file base or some kind of old, there's something called Kix as kind of an operating system that these things work with that allow you to talk to them. And so we tend to have connectors for those kind of old kind of APIs. And that helps you pull in that kind of capability and then create new services and new APIs on top of them. So it's called legacy modernization. There's a lot of that going on.
If you're trying to decide between hand coding and purchasing a platform to save you some time, like how do you make that decision?
We should definitely talk about that offline, right? There's a lot of things to be considered in that, but the usual approach is not to go in and modify the code. Usually there's some kind of interface that the code offers. Obviously for a game that may be literally a user interface, and there are people out there who literally will screen scrape and create interfaces on top of that. But usually we attach to the interface that the thing already exposes in some way. Exactly, including CSV, including command line and so on.
There you go. I knew you'd have a better answer than I did. Any other questions? Okay, great. Thank you. Thanks very much.